We are Projeto Jupiter from Universidade de São Paulo, Escola Politécnica. Today, we are presenting mission ID 53, named Carpo, which is competing in the solid propulsion category at LASC 2026. Our focus with this rocket is to achieve maximum structural efficiency and apogee precision by utilizing an advanced solid motor system. Carpo is an extremely agile and optimized rocket. It has a total length of 2.4 meters and a diameter of 105.8 millimeters. Its airframe is divided into 4 modular sections: avionics, recovery, payload, and motor. The entire structure is manufactured from fiberglass using the wet layup process on a cylindrical mandrel, with an isotropic fiber orientation to maximize resistance to axial loads. Our 4 fins feature a NECA 0012 profile and a trapezoidal geometry. They are constructed with a high-precision EBS core sandwich structure, encapsulated in layers of quasi-isotropic fiberglass and bonded to the motor casing with high-strength structural epoxy. Furthermore, to meet the category's stability and weight requirements, the rocket carries a 0.8 kg passive payload configured as high-density mechanical ballast. A liftoff weight of 11.7 kg, the vehicle is designed to reach a nominal apogee of 1,000 meters, where the parachute deploys in a reefed mode, descending at 23 meters per second. At 400 meters above ground level, our system triggers the pyrotechnic line cutters for the main parachute disreefing, decelerating Carpo to just 10 meters per second upon landing. The parachute is ejected using a CO2 cartridge mechanism, a system that has already flown successfully in several of our team's historical missions. To control this ejection system and acquire flight data, the electronics team developed the avionics module, positioned in the rocket's nose cone. This system utilizes 2 altimeters, one COTS unit, the RRC3, and one SRAD unit, the apogeótico. These are responsible for monitoring altitude-detecting apogee and ensuring the deployment of both parachutes at the programmed altitudes. Furthermore, for telemetry, we also utilize an SRAD transmitter. It is responsible for broadcasting GPS data and sensor readings via a LoRa module. All this data is transmitted directly to the ground station, where the team can track flight graphs in real time and monitor the rocket's exact location, facilitating the recovery team's operation. The heart of Mission Carpo is composite propellant motor, designed to deliver a total impulse of 2.8 Newton-seconds and a peak thrust of 1024 newtons, with a burn time of 5.2 seconds. The combustion chamber, manufactured from aluminum with a 4.5 mm wall thickness, houses 3 base grains of ANCP, composed of ammonium nitrate, sulfur, aluminum, and neoprene, totaling 1.4 kilograms of propellant. The reliability of this motor is backed by our hands-on experience. We had successfully conducted 2 static fire tests since the beginning of the motor's development. For the current cycle, we will validate the structure with a hydrostatic test at 1.5 times the operating pressure, followed by further vertical static fires, monitored via wireless telemetry using pressure transducers and load cells for maximum safety. Flame inhibition is achieved using polyaramid laminated with epoxy resin on the outer surface, ensuring excellent flame resistance. Internally, we utilize fiberglass epoxy as a thermal liner for the chamber. The nozzle is machined from graphite with a 5.75 mm throat diameter. Mission Carpo reflects Projeto Jupiter's commitment to advancing composite propellant rocket engineering in Brazil, combining lightweight, construction, power, and repeatability. We are ready to take Carpo to the skies at LASC 2026 and contribute to yet another great chapter of university aerospace sports in Latin America. Thank you very much and see you at the 7th edition of LASC.